All right, guys, here's lesson four. It's accuracy and precision. I didn't make the PowerPoint myself, but I just stole it off the internet. It's just easier because this is literally going to be like a 5 to 8 minute lesson total. And then that way you'll be able to do um, a do now for Thursday, and then Friday and Monday, you guys will be able to review and go from there. So when we talk about measurements and we talk about values, we talk about accuracy and we talk about precision. So, perfect example of accuracy is this bullseye. What is always the ultimate goal of the bullseye? Hit it in the middle, right? That's what you want to do. That would be considered an accurate shot if you hit it near in the middle as a bullseye or anywhere near the bullseye. Whether or not you're precise, that's a different story. We talk about that in a different way. But accuracy is how close a measured value is to the actual true value. So, perfect example, bullseyes, golf course. You're in the fairway. You want to hit a ball to the green. You want to get it to as close to the hole as possible. So to be accurate, the best accuracy would be put it in the hole, just like a bullseye on a target. But if you hit three balls and they're all near each other but not near the hole, they would be considered precise, but they wouldn't be considered accurate. And we're going to talk about that. So accuracy is how close you are to the measured value, how close a measured value is to the actual or true value of what you're doing. So in this case, these three arrows, this one, not really accurate. This one, definitely not accurate. Same area as this one, just below. This one, right on the money. Okay, so this would be considered, this middle arrow would be considered accurate. The other two would be not. So looking at this slide, remember, accuracy's definition is how close a measured value is to the actual true value. So the actual value is, in this case, is 4,137 cubic centimeters. Of these four groups, group one, group two, group three, or group four, which one of these is actually closest or the most accurate to the true value? So let's look at the measurements. Group one, 5658. Not bad. Group two, 4393, pretty good. Okay. Group three, 188,326, not even close. Talk about it when we talk about statistics and we talk about outliers, that's an outlier right there. And then group four's measurement is 151 centimeters cubed. Again, way off. So you good, me? Okay. Okay. Now, precision, on the other hand, as you can see, you're welcome, is how close the measured values are to each other. It doesn't have anything to do with accuracy. It has more to do with what the numbers are together as a group. If they're very bunched together, that is going to mean that they are precise. It doesn't necessarily mean that they're accurate. So in this case, these five balls here would be considered precise, but not really accurate because they're not close enough to the bullseye. Okay. So precision is how close the measured values are to each other. Accuracy is how close they are to the actual true value. So in this case, these would be precise, not necessarily accurate. So here's your actual value, 800 centimeters cubed. Okay. Trial one, you measure 191. Trial two, you measure 198. Trial three, you measure 200. And then finally, trial four, you measure 196. Here's your actual value. Keep that in mind. Your actual value is 800 centimeters cubed. No, none of these are even remotely close to being accurate. But they are all within 9 cubic centimeters of each other, which will tell you that they are precise, but not accurate. Okay. They're precise because they're all close together. They're all bunched together within 9 cubic centimeters of each other, but the actual value is 800. They are nowhere near 800. Okay. So when we look at this, here's some bullseyes or targets with bullseyes and some with not bullseyes. Okay. These three here, right in the middle, all right in the middle, they hit exactly where you wanted them to hit. They're also all bunched together. So that means they're going to be precise. Okay. These are all together, but they're not in the center of the bullseye. So they are not considered to be accurate. They are precise, but they are not accurate. Okay. And then these three arrows, none in the bullseye, none really close to each other. They're as a group, they're not really close to each other. So therefore, it's neither accurate nor precise. Okay. Because they're spread out all over the place. So also, accuracy can be also expressed as an average of several measurements. So in this case, you have these 5 difference, okay, or these 4 different trials. Trial 1 came up with 8 centimeters cubed. Trial 2, 6 centimeters cubed. Trial 3 is 11 centimeters cubed. And trial 4 is 15 centimeters cubed. So you have 2 under and 2 over. It could be close. So you add up the numbers. 8 plus 6 is 14. 14 and 11 is 25. 25 and 15 is 40. You have 4 trials. You divide 40 by 4 and you come up with 10 centimeters cubed. So the average of the data would be considered accurate. Is it precise? Not really, because you're dealing with, you go from 6 to 15. So there's a 9 cubic centimeter difference and the actual value is 10. So no, I would not say that they are precise. All right. And then there's one last thing when we talk about accuracy and precision: bias. And we talk about this also in the scientific method, and we talked about this with data as well. And that's all these are. You're analyzing data here. Bias is systemic or systematic, which means it's going to be built in, and it's an error which makes all measurements wrong by a certain amount. So the examples of bias are scales can read 1 kilogram. And this happens all the time when you go to like ShopRite or Acme and you go get deli meat sliced or whatever. Sometimes you will see that the scale is a little offset. That's part of the bias. Okay. Another part of the bias would be measuring your height wearing shoes with thick soles. So it adds a little bit of height to what you're trying to measure. A stopwatch that takes a half a second to stop when it's clicked to stop that time. So there's always going to be those little types of bias that could affect and throw off the accuracy of your numbers. So, and if you measure something several times and all the values are close or they're precise, they may still all be wrong if there is a bias that's involved. So precision is dealing with the numbers as a group. Accuracy is dealing with the actual, where is it actually going? Where's the arrow going on the target? Where is the number that you've measured in relationship to the actual value itself? So that's accuracy and precision. And like I said, this is the easiest way to look at it and understand it. Accurate and precise here because everything's in the bullseye. Just above the bullseye, they're all together, but they're not accurate. So that means they're precise. And then these 3 that are all spread out all over the place, that is neither accurate nor precise. And if there was like for this one, if there was a 4th arrow that was saying like up here, you could throw that out. But we'll talk about more about that later on in the year. So hopefully that makes sense. This is lesson 4. This is the end of the unit, so we're going to stop. We're going to go from there. You guys will have a due now in the next couple of days, and then we'll review, and you'll have the test on October 1st. Deuces.